Hello everyone and welcome back to PostNetwork Academy. Today we are diving into some fundamental concepts in probability and statistics, that is expectation and covariance. Specifically, I will cover the addition and multiplication theorems of expectation and how they relate to covariance. So, without further delay, let's get started. So here is the outline what we will learn. So introduction, addition theorem of expectation, proof of addition theorem, multiplication theorem of expectation, proof of multiplication theorem, and covariance. So basically in the last video we have learned that expectation or expected value is a fundamental concept in probability and statistics, and that provides a measure of central tendency of a random variable. And we will discuss two theorems, addition and multiplication theorems of expectations. So first theorem is that if there are two random variables x and y, so sum of their expectation is equal to expected value of x, expected value of y, and their addition. So that is linear, you can say that. And if there are n random variables, so expectation will just get distributed. That means expected value of x1 plus x2 till xn, that is equal to expected value of x1, expected value of x2, expected value of xn. Now this theorem holds regardless of whether the variables are independent or dependent. Let us see the proof of the theorem. So expected value of random variable x, you can write like this one, x into probability distribution of x, and for a y you can write the same way. Now see that, just write expected value of x plus y, that is x plus y, and that is the joint distribution. And see that here just distributing the sum, and thereafter here basically how this has come. So you can observe that this expression we can write here summation over x, here x, and summation over y, px, p is equal to x and p is equal to y. And you can observe that this is the marginal distribution of x. So this will become summation over x, x, p, x, right? The same way you will get this one. That means summation from y, y, px. So that will become, this expression will become this one, and this expression become this one. And you can observe that these are the expectation of random variable x, and this is a random variable y. So here is the point that this is the marginal distribution. You can write this expression like this one, and this is the marginal distribution of x. It means distribution function of random variable x. Now let us see that the second one. And here the condition that these two random variables are independent, then this condition will hold. Always remember. So the same here you can write separately, and just very easy to prove that. Just write it separately. And here that is expected value of x, that is expected value of y. So expected value of xy is equal to expected value of x into expected value of y. Now let us understand covariance. So covariance is defined as between two variables, frequency of here, frequency of x here, and you can say that y, and finally see that for a probability distribution, this one you will get x minus expected value of x, y minus expected value of y, and this is the distribution, joint distribution probability. The same way here, x minus expected value of x, y minus expected value of y, and this is the joint distribution. So for two random variables, this was the covariance, and in the form of expectation you can write like this one. And see that if x and y are independent, then covariance will become 0, and that means expected value of x y will be equal to expected value of x into expected value of y when both are x and y are independent. So hope you understood the concept. For a more post and videos PDF, you can visit www.postnetwork.co, and I hope you will support my YouTube channel and you will subscribe and like other videos that motivate me to make more videos. Follow Facebook page and also follow LinkedIn page. So hope you understood the concept, and you will also support me, and you will go to subscribe YouTube channel, Facebook page you will follow, and LinkedIn page you will follow. So thanks for watching the video.